Preparation of alcohols. Alcohols can be prepared from fermentation, hydration of alkenes, hydrolysis of haloalkanes, and addition of Grignard reagents to carbonyl compounds. Fermentation is a chemical process in which microorganisms, for example yeast, act on sugar to produce ethanol and carbon dioxide. So the alcohol produced must be ethanol and carbon dioxide, not other alcohol, just ethanol. Hydration of alkenes. The reactants are alkene and water. Because it's hydration, condition is acid H2SO4 sulfuric acid, and this reaction must follow Markovnikov's rule. Markovnikov's rule states that hydrogen will be added to carbon that has greater number of hydrogen. So H and OH are aided in hydration of alkenes to produce alcohol. Next, hydrolysis of haloalkanes. The reactant are haloalkane and sodium hydroxide or water. So both can be used in hydrolysis of haloalkanes to produce alcohol. The halogen in haloalkane will be substituted by OH minus from sodium hydroxide or from water. It depends on the reactant. So example, bromoethane react with sodium hydroxide. This bromide will be replaced by hydroxide ion from sodium hydroxide to produce ethanol and NABR. 2-chloro-2-methylpropane as the haloalkane reacts with water, so this chlorine will be replaced by hydroxide ion in water to produce 2-methyl-2-propanol and HCl. Addition of Grignard reagent to carbonyl compounds. Primary, secondary, and tertiary alcohols can be prepared by addition of Grignard reagent with carbonyl compounds followed by hydrolysis. So basically, alcohols with different classes can be prepared if you use Grignard reagent with carbonyl compounds. This is the general equation. Aldehyde or ketone, because both aldehyde and ketones are carbonyl compounds, react with Grignard reagent or group attached to MgX. X is a halogen. So in order to produce Grignard reagent, you must have haloalkane reacts with magnesium in dry ether, and the product is Grignard reagent. So the product react with carbonyl compounds, whether it's aldehyde or ketone, in the presence of ether and acidified water, the product will be alcohol. So it's either primary, secondary, or tertiary alcohol. The product will depend on the reactant, whether you use aldehyde or ketone. If you want to form primary alcohol, you must use Grignard reagent and methanol. Methanol is the carbon has no R group at all, means this carbon, the carbon double bond oxygen, C double bond O, has no carbon attached to it at all. So this is methanol. If you want to form primary alcohol, you must use methanol react with Grignard reagent. So the R group, delta minus, more electronegative R group in Grignard reagent will attack slightly positive carbon in methanol, and this one of the double bond, one bond of the double bond, the 2 electron in this bond will be given to the oxygen, and this oxygen will have one lone pair, 2 electrons from this bond, react with dry ether, so the oxygen will be O minus, and the Mg, this Mg, because these R is already bonded to this carbon, leaving this Mgx delta plus, this Mgx delta plus will bind to the oxygen O minus. And then this compound will react with acidified water to produce alcohol. So this alcohol only has one R group attached to this carbon, so this is primary alcohol. Example, this is the haloalkane producing Grignard reagent, react with formaldehyde, common name for methanol, react with ether, O minus and MgCl plus, react with acidified water to produce 1 pentanol. This carbon only attached to one carbon, so this is primary carbon, and this is primary alcohol. Formation of secondary alcohol. In order to produce secondary alcohol, the reactant must be Grignard reagent plus aldehyde, and the aldehyde cannot be methanol. It must be other than methanol, means the aldehyde has one R group only. It must have one R group. So same goes to the mechanism of the primary alcohol. Previously the mechanism is the same, but this carbon has one R group. So the product will be secondary alcohol because this carbon attached to 2 more carbon, making this compound secondary alcohol. This is the example for formation of secondary alcohol. Here we use acetaldehyde, carbon only attached to one R group, only attached to one C, the other side is H. So this is a product 2-butanol. The carbon has 2 carbon attached to it, so this is secondary carbon, making this compound secondary alcohol. Formation of tertiary alcohol. The reactants are Grignard reagent and ketone. So this time in tertiary alcohol we must use ketone. Unlike secondary and primary alcohol, both we use aldehyde, but for tertiary alcohol we use ketone. Note that all 3 are carbonyl compound. We have Grignard reagent reacts with ketone, carbon attached to 2 other carbon, this carbonyl carbon attached to 2 other carbon, it is ketones, in dry ether, and the product is tertiary alcohol because this carbon attached to 3 other carbons, and this is tertiary carbon, making this product tertiary alcohol. This is an example for formation of tertiary alcohol. Grignard reagent reacts with acetone in dry ether. Acetone is ketone because this carbon has 2 other carbons attached to it, and this carbon has double bond O, so this is ketone. Grignard reagent reacts with ketone, producing tertiary alcohol. This carbon attached to 2 other carbon, making this carbon tertiary carbon, so this compound is tertiary alcohol.